In this video, we are going to learn logarithmic differentiation. Normally, the logarithmic differentiation methods we are going to use for the more complex functions. But here, understanding how it works, how the function is working, or logarithmic differentiation is working, we are using one easy function like polynomial function. This is normally the questions like these we are going to solve by using the logarithmic differentiation. Okay, for understanding the logarithmic differentiation, firstly we should remember about the logarithm base a b times c, the formula. If you remember, if there is a multiplication in the main part, which is called also augment, okay, and logarithm base a plus logarithm base a b plus, logarithm base a b plus logarithm base a c, it should be. So if there is multiplication inside the logarithm, outside we are going to take it outside as an addition and individual logarithm base a b logarithm base a c. If we apply this one to the ln, because we are going to use ln form here, it's going to be like this: ln fx is equal to, I got the ln of this expression. If I got ln here also, ln x times 3x minus 1 times x squared plus 3 is going to be, I'm going to write in big parentheses. Okay, then we have to remember this rule here for the ln. If I write this one for ln bc, ln bc is going to be equal to ln b plus ln c, where the base is e, which is the base of the natural logarithm. Okay, then in the second step for this kind of questions, first we are going to get ln. So firstly, I'm going to get the derivative of both sides. I'm going to give the derivative of both sides for getting the derivative of this expression, this complex expression, and I'm going to get the derivative of ln here. And here, before starting to do operation, I have to separate these parts, because this is ln x plus this expression is going to be equal to ln fx. ln fx derivative is going to be equal to ln x plus ln 3x minus 1. Now I'm applying this rule here: ln b times c, ln a times b times c is equal to ln a plus ln b times ln b plus ln c, it's going to be, which is x squared plus 3 derivative. So I'm going to get the derivative of this expression. And we have to remember, normally last lesson we learned this one, ln fx derivative. If you remember, the ln fx derivative is equal to f derivative x over fx, it's going to be. So for all these expressions, I'm going to apply the same rule: f derivative over fx is going to be equal to the derivative of ln x. For the first question, I'm going to write it one by one like this, because the addition is not going to affect the operation here. Ln x derivative plus ln x squared plus 3 derivative is going to be. Okay, and then here f derivative x over fx is going to be equal to derivative of ln x. If you remember, it's going to be x derivative over x, which is equal to 1 over x. So here let me write ln x derivative. Okay, plus 3x minus 1 derivative over 3x minus 1, and plus x squared plus 3 derivative over x squared plus 3 is going to be. Okay, then Here this is going to be equal to f derivative x over fx is equal to 1 over x plus the derivative of 3x minus 1 is going to be equal to 3 over 3x minus 1, 3x minus 1, and the derivative of x squared plus 3 it's going to be equal to 2x over x squared plus 3. Normally we finish the derivative, but here we couldn't find the f derivative x. The question is asking f derivative x, what is it? So f derivative x is going to be equal to, when I send this fx to the other side, it should be in term of multiplication. That's why I'm going to write in the term all the other terms like this. Sorry, minus 1 plus 2x over x squared plus 3 it should be. And in the last step only I'm going to write what is the value of fx. The value of fx, if you remember, the product of these 3, which is equal to x times 3x minus 1 times x squared plus 3 times all this expression 1 over x plus 3 over 3x minus 1 plus 2x over x squared plus 3 is going to be. As you see, this expression is more complex than the previous one. If you try to get the derivative of this expression, first you should get the divisions derivative, then the multiplications derivative, and all these expressions has difficult powers. That's why you are going to get here, this is the 1 over 3 the power is. So you have to find the powers one by one here, the derivative of the powers one by one. That's why it's going to be too long for us. But ln logarithmic differentiation solve this problem easily. Ln fx is going to be equal to ln x 3 over 5 times I'm going to write this expression as a power form, x squared plus 1 to the power of 1 over 3 over 2x plus 1 to the power of 7. So here the ln fx derivative, the derivative of all this expression is going to be 1 by 1. I'm going to write here. Here, f derivative x over fx is going to be equal to ln x to the power of 3 over 5 plus ln x squared plus 1 to the power of 1 over 3 minus, because when we have division in the logarithm, if you remember, outside we were getting as a subtraction, so 2x ln 2x plus 1 to the power of 7 is going to be derivative. And the easy part here, you can take these powers in front of the logarithm, because logarithm base a b to the power of n, it was equal to n times logarithm base a b. So f derivative of x over fx is going to be equal to the derivative of 3 over 5 times ln x plus 1 over 3 times ln x squared plus 1 plus minus 7 times ln 2x plus 1 derivative. Here these are coefficients, that's why they're not going to affect the derivative operation, and there's addition sign and subtraction sign we have here. This operation is not going to affect the derivative operation again, so I can get the derivative of all these expressions one by one. So f derivative x, I'm going to keep one step also here, that's why I'm sending this one to the other side, and it's going to be equal to derivative of 3 over 5 times ln x derivative, if you remember, 1 over x, it's going to be plus 1 over 3, it's not going to affect, is going to be x squared plus 1 over x squared plus 1, x squared plus 1 derivative over x squared plus 1 minus 7 times ln, no more ln here, minus 7 2x plus 1 derivative over 2x plus 1 is going to be. Okay, I got the derivatives here, this derivative sign get inside, and I got one by one the derivative of these expressions here. Derivative of ln x squared plus 1, x squared plus 1 over x squared plus 1 derivative over x squared plus 1 it should be. Okay, then this is the last step it's going to be. I'm going to write what is the value of fx, and I'm going to write the derivative of these expressions. If you remember the fx here, it was written at the beginning here, x to the power of 3 over 5 times cube root of x squared plus 1 over 2x plus 1 to the power of 7 is going to be. Okay, then times 3 over 5x plus x squared plus 1 derivative is going to be equal to 2x over 3 times x squared plus 1 plus here, and there is going to be minus. The derivative of 2x plus 1 is going to be equal to 2, so 7 times 2 is going to be equal to minus 14. Minus 7 times 2 is going to be minus 14 over 2x plus 1, it should be. And this is the derivative of the expression is going to be. In the previous two questions, we can use different methods, but for this question, we don't have another method to solve the question. Here, this function is neither polynomial nor exponential function, because in the polynomial function, the power is a number. In the exponential function, base is a number, the power is function. Here, power and base both function. That's why while we are getting the derivative of this expression, only we can use logarithmic differentiation method. Okay, after this explanation, let's get fx, ln fx here. Ln fx is equal to ln x to the power of x. This power comes in front of the logarithm, and ln fx is equal to x times ln x. And if I get the derivative of left side, I will get the derivative of the right side, and this is f times g derivative. So f times g derivative, one more time for this question, I'm writing f derivative times g plus f times g derivative is going to be. So ln fx derivative is going to be equal to f derivative, which is x derivative times ln x plus x times ln x derivative is going to be. Okay, if you remember what was the value of the ln fx derivative, f derivative x over fx, it's going to be equal to x derivative is equal to 1 times ln x plus x times 1 over ln x derivative. If you remember, it was equal to 1 over x, so x times 1 over x, if you simplify, it's going to be ln x plus 1. F derivative x, I'm going to send this term to the other side now, is going to be equal to fx times, now I'm writing this part in the parenthesis, 1 times ln x is equal to ln x plus x times 1 over x. I simplified and I said it's equal to 1, so the expression it becomes like this. Then we are going to replace the value of fx. Fx is equal to here, fx is equal to x squared times, here I forget f derivative x, and I forget the fx is not x squared. Fx is equal to, if you remember here at the beginning it was written fx is equal to x to the power of x, so it's going to be equal to x to the power of x times ln x plus 1 is going to